Hello tech lovers! Welcome to the fourth lesson of the course Digital Wireless Communication from 2G, 3G and 4G LTE. In this lesson, we are going to talk about error management. Here, we discuss the techniques that are used to minimize the number of errors in the received signal, notably for word error correction and retransmission. But first, don't forget to hit the subscribe button, activate the bell to be notified when I upload a new video, like, share, and leave your comments below. Join our group on Facebook, the link is in the description. In the past lessons, we saw that noise and interference lead to errors in a wireless communication receiver. These are bad enough during voice calls, but they are even more damaging to important information such as web pages and emails. But fortunately, there are several ways to solve the problem. The most important technique is for word error correction. In this technique, the transmitted information is represented using a code word that is typically 2 or 3 times as long. The extra bits simply additional, redundant data that allow the receiver to recover the original information sequence. Let's see, for example, a transmitter might represent the information sequence 101 using the code word 1100101111. After an error of the second bit, the receiver might recover the code word 1000101111. If the coding scheme has been well designed, then the receiver can conclude that this is not a valid code word, and that the most likely transmitted code word was 1100101111. As you can see, the receiver has therefore corrected the bit error and can recover the original information. The effect is very like reading English, which contains redundant letters and allow the render to understand the underlying information, even in the presence of spelling mistakes. The coding rate is the number of information bits divided by the number of the transmitted bits, 1/3 in the above example. Usually, for word error correction algorithms operate with a fixed coding rate. Despite this, a wireless transmitter can still adjust the coding rate using the two-stage process shown in this figure. In the first stage, the information are passed through a fixed rate coder. The main algorithm used by LTE is known as a turbo coding, has a fixed coding rate of 1/3. Oh, talking about LTE, you can watch our 4G architecture course. It's great, guys. Link up here in the card or down here in the description. Let's get back to the point. In the second stage, called rate matching, some of the coded bits are selected for transmission, while the others are discarded in a process known as puncturing. The receiver is a copy of the puncturing algorithm, so it can insert dummy bits at the points where information was discarded. It can then pass the results through a turbo decoder for error correction. Changes in the coding rate have a similar effect to changes in the modulation scheme. If the coding rate is low, then the transmitted data contain many redundant bits. This allows the receiver to correct a large number of errors and to operate successfully at a low SINR, but at the expense of a low information rate. If the coding rate is close to 1, then the information rate is higher but the system is more vulnerable to errors. LTE exploits this with a similar trade-off of the one we saw earlier, but transmitting with a high coding rate if the received signal SINR is high and vice versa. ARQ, or automatic repeat request, is another error management technique, which is shown in this figure. Here, the transmitter takes a block of information bits and uses them to compute some extra bits that are known as a cyclic redundancy check, or CRC. It appends these to the information block and then transmits the two sets of data in the usual way. The receiver separates the two fields and uses the information bits to compute the expected CRC bits. If the observed and expected CRC bits are the same, then it concludes that the information has been received correctly and sends a positive acknowledgement back to the transmitter. If the CRC bits are different, it concludes that an error has occurred and sends a negative acknowledgement to request a retransmission. Positive and negative acknowledgements are abbreviated as ACK and NACK respectively. A wireless communication system often combines the two error management techniques that we have been describing. Such a system corrects most of the bit errors by the use of forward error correction and then use automatic repeat requests to handle the remaining errors that leak through. Normally, ARQ uses a technique called Selective Retransmission, in which the receiver waits for several blocks of data to arrive before acknowledging them all. This allows the transmitter to continue sending data without waiting for an acknowledgement. But it means that any retransmitted data can take a long time to arrive. Consequently, this technique is only suitable for non-real-time streams such as web pages and emails. Hello tech lovers! Thanks for watching and don't forget to like and share the video. I am launching one lesson per week, so it is important that you subscribe and activate the bell to be notified when I upload a new video.